In this video, we're going to see where the quadratic formula comes from. We'll start with the general form of a quadratic equation, and we'll work through some steps and end up at our quadratic formula. Before we get started, I recommend watching the video on completing the square because we're going to use that technique in this video. Okay, let's get started. Let's begin by asking, what is the quadratic formula? What does it do? If we have a quadratic equation and we know a, b, and c, we can plug those values into the quadratic formula and it'll give us the roots of the parabola. As we've seen, when we plot our quadratic equation on the xy chart, we get a shape called a parabola. The parabola has two important points, which are in purple here. Those are called the roots. That's where the parabola crosses the x-axis. For each of those points, the y value is 0, and our quadratic formula helps us find the x value. So looking back at the quadratic equation, the roots are the solutions to this equation where y equals 0. So if we plug in 0 for y, and we solve this equation for x, we should get the quadratic formula. Solving for x here would give us the solutions where y equals 0. Those are the roots. So the question is, how do we solve for x? We have an x squared here and an x here. Somehow, we need to get x on one side of the equation so it looks like our quadratic formula. So the fancy math folks, they tried different ways to do this, and they finally figured it out. So we're going to start off by rewriting our equation to get the variables on the left side. So we'll have ax squared plus bx plus c equals 0. And we're going to divide both sides of the equation by a. Now, looking at the left side, we have a fraction that we can split up into 3 parts. We have ax squared over a plus bx over a plus c over a. And on the right side, 0 divided by a is just 0. Looking at our first term, we can cancel out our a's, leaving us with x squared. Our second term, we're going to rewrite as b over a times x, and we'll leave the rest the same. We'll continue by subtracting c over a from both sides. That gives us x squared plus b over a times x equals negative c over a. Now we're at the step where we're going to complete the square. So we'll have x squared plus b over a times x plus some term. And on the right side, we're going to add that same term. That term that we add is going to make the left side into a perfect square. And as we've learned, that final term is going to be equal to the middle term, which is b over a divided by 2, and all of that squared. Substituting that in, we'll have b over a divided by 2 squared. b over a divided by 2 is the same as b over a times 1/2. Multiplying the fractions, we'll have b times 1 on top and 2 times a on bottom. So this is the term that we're going to add to both sides. b over 2a, that quantity squared. Let's bring that down to the next page and keep on working. Since our polynomial on the left is a perfect square, we can rewrite it as x plus smiley face times x plus smiley face, where smiley face squared is going to be equal to our final term, b over 2a, that quantity squared. If smiley face squared is equal to b over 2a squared, that means that our smiley face is equal to b over 2a. That means we can rewrite our perfect square as x plus b over 2a, our smiley face, times x plus b over 2a. And that's going to equal the right side from above, negative c over a plus b over 2a squared. So our left side we can rewrite as x plus b over 2a squared. And we're going to rewrite our right side. So we have negative c over a plus, and b over 2a squared we can rewrite as b over 2a times b over 2a. Let's keep on working with this right side. So we have negative c over a plus, and we can multiply those two fractions. So b times b is b squared, and 2a times 2a is 4a squared. Now we have two fractions here. Let's get common denominators. If we multiply our first fraction by 4a on top and bottom, then our denominator is going to be 4a squared. So it'll match the second fraction. Simplifying that, we have negative c times 4a over 4a squared. Adding those fractions, we have negative 4ac plus b squared over 4a squared. Again, we were just rewriting the right side. We still have the left side to work with, so how about we bring that down, that x plus b over 2a squared. So we'll have our x plus b over 2a squared is equal to, and on the right side we have our fraction. We'll rewrite the numerator as b squared minus 4ac, and all of that is over 4a squared. You might be able to notice we're getting closer to our quadratic formula. Just a few more steps. Now, if x plus b over 2a squared is equal to the right side, that means that x plus b over 2a is the positive or negative square root of the right side. Now we're going to rewrite the right side again. Using our properties of square roots, we can rewrite the right side as the square root of b squared minus 4ac divided by the square root of 4a squared. Using another one of our properties, we'll focus on the denominator. We can rewrite that as the square root of 4 times the square root of a squared. Let's bring the left side down again. We have x plus b over 2a is equal to positive or negative square root over b squared minus 4ac. And on the bottom, we have square root of 4, which is 2, and the square root of a squared, which is a. Now we'll subtract b over 2a from both sides. And that leads to x equals negative b over 2a. And we have our positive or negative, which we can think of as plus or minus the square root of b squared minus 4ac over 2a. Now onto our final step. We have two fractions with common denominators, so we can add our numerators. We'll have negative b plus or minus the square root of b squared minus 4ac, all of that, over 2a. And now we have our quadratic formula. We found the values of x that correspond to y equals 0. In other words, we found the roots. We found where the parabola crosses the x-axis.